Hey Pritzker, we're back. This is Objective 110. Students will be able to find factors and factor pairs of given numbers. We're actually going to ignore this vocabulary for right now. We'll come back to it and get it in just a second. But I want to go straight into some practice because this is definitely a skill that you have seen before at some point in time. And I want to remind you all that you're already probably pretty good at it. Alright, so we're here on page 2. This is steps to find all the factors of a given number. The first suggested step is to take the square root. Just in case you're confused what that means, if I had 9, the square root of 9 is just 3. So take the square root and round to the nearest integer. If it already is an integer, that's good. If you have like 11, take the square root, and then whatever answer you get, round to the nearest whole number. After that, you're going to list out those integers from 1 to that number. So let's say right here for the square root of 9, I got 3. I'm going to list out 1, 2, 3. You'll see in a second how this is really helpful in finding factors. Number 3, just divide the value, like whatever you're trying to factor, divide that by these integers you found. That was a lot of information. Let's actually go through an example, and I think it'll make a lot of sense. Right here, trying to find all factors of the number 36. You might have seen it as like a T-chart in middle school where you just found like, 1, 36, so on and so forth. You might have seen it as rainbow factoring. Like you have this number 36, and you have 1, and then 36, and it connects, and then 2, and 18. But in some way, you've almost certainly seen factoring before. We have a suggested different method at Pritzker, which we think is equally effective. Ultimately, it is up to you. Like you are the student, you know yourself better than we do. But this is a really consistent way to find factors. First, we're going to take the square root of this number. Okay? So the square root of 36 is 6. Okay? So we found that square root is 6. Now we're going to list out all of the integers 1, 2, 6. So right here we're going to list 1, 2, 3, 4, 5, and 6. Now we're going to divide 36 by each of these values. So right here I'm going to write 36. I'm going to do a slash for divided by. If you want to do the divided by sign, that's totally cool. I'm going to do 36 divided by each of these values. When you do that, you get 36. And that just tells you that 1 and 36, like those are factors of 36. When you divide it by 2, you get 18. That tells you that 2 and 18 are both factors of 36. Keep that going. 3 and 12. 4 and 9. And this is really interesting. Go ahead and do 36 divided by 5. And you get 7.2. For it to be a factor, it has to divide evenly. Now, 5 times 7.2, that is 36, but 7.2 is not an even whole number. So it just means that 5 is not a factor of 36. So just cross through that. And last, you get that equals 6. So 6 times 6 equals 36. You'll see now we're not going to double those factors. I found all of my factors here. So what I'm going to do is list them out. The factors of 36 are 1. I like to go in order from least to greatest. 2, 3, 4, 6. I'm just going to list it once. There's no need to list it again. We have 9, 12, 18, and 36. Right here are all the factors of 36. So again, like, this might not be your preferred method, but we want to see this in your homework. We want you to at least give it a fair shot. And afterward, if you still like the way you factored in middle school, that's totally fine. We're going to do another example now. Looking at example 2, this is find all the factors of 45. We're going to start the same way. This would be really cool if you would pause the video and try it completely on your own first and see can you do this without me walking you through. If you feel like though you need another example, then just follow along. Square root of 45. We get, I'm going to say 6.08. Sorry, 6.708. This is really important because right here, we need to round to the nearest whole number because that makes sure that we check all the values that could possibly be factors. So I'm trying to round to this whole number. This is the ones place, the integers place or the whole numbers place. I'll look next door. It's going to round up to 7. So now I'm going to list all my numbers 1 through 7. 1, 2, 3, 4, 5, 6, and 7. I list these numbers out.
Mr. Riggs, I have a question.
Go for it.
Why do we take the square root of the number?
It's a really great question. A lot of students, when they're trying to factor, like they don't really know where to stop. So like they're doing like 45 divided by 10, divided by 11, divided by 12, like all the way up to 45. That's way too time consuming. If we take the square root, it gives us a value that we can stop checking at. That's our sign that we have found all of the possible factors. Right? Because at that square root, you're finding like the biggest possible factor, like that even number times itself. And so that just tells us like we don't need to go past 7 once we've checked that. We've checked all the possible factors. So now we're going to check these numbers. We're going to take 1, 2, 3, 4, 5, 6, 7, and do 45 divided by each one of those values. Again, this is just saying 45 divided by 1, divided by 2, so on and so forth. If you just want to use that division symbol, that's fine. Personal preference. We start here. 45 divided by 1 is 45. Here's my first. This is called a factor pair. We'll define this on the next page in a second, or on the first page rather. When we do this, we get 22.5. So the fact that we got a not even number, sorry, not whole number, it just means that 2 is not a factor of 45. Which makes sense. This is an even number. 45 is an odd number, so even numbers are not going to be factors of odd numbers. We get 15 here. Means that 3 and 15 are factors of 45. 45 divided by 4, we get 11.25. Again, we get a not whole number, so this means that 4 is not a factor of 45. We get 9, so we have 5 and 9 are factors of 45. These last two, we get 7.5 and
6.428.
So on and so forth. Notice how these are both not whole numbers. This means that they're not factors of 45. So if you look at what we circled here, I'm trying to list out my factors of 45. I have 1. And again, I like to go these two grades. I think it's a good idea. 5, 9, 15, and 45. And here are all my factors. 1, 3, 5, 9, 15, 45. All my factors of 45. Okay. We're going to go back to the first page now, because we're using a lot of words like factors, divisible, and factor pairs that maybe we don't quite know yet, and we want to make sure we have good definitions for these. When we're defining these words, I'm sure Ms. Hydra's going to hop in a decent amount, because I struggle to recall the best definition, so be patient with us as we hope you try to understand these words. First one is a factor, but I personally like to think of a factor as a number that multiplies to get another number. So I think about it as, 3 is a factor of 15. Because 3 can multiply times 5 to get 15. So that's how I like to think about factors. But I know Ms. Hyder has a different definition that she prefers.
I also like to think about multiplication and division as very similar operations. So I like to think of factors as numbers that also divide a number evenly.
Again, this hashtag symbol, this is us being lazy and writing numbers. You can also think of it as numbers that divide another number evenly. So again, let's use a number of, 15. We're trying to find factors that I can think about, 3, I know it's times 5, gets me to 15. These multiply together to get here, so they're both factors of 15. But you can also think of it as, 15 divided by 3 gets me to 5. So these go in evenly, so they also are factors for that reason. So whatever makes more sense for you. Now, factor pairs, two numbers that multiply. To get a target number. Again, 15 is a really good example. If I'm thinking about a factor pair of 15, I know that 3 times 5 equals 15. 3 and 5 would be considered that factor pair. They're the two numbers that multiply to get 15. But again, you can think about it with the way that this higher makes you think about it. You can think of it as two numbers that can divide that target number we can make. I can prove that 3 and 5 are a factor pair of 15, because I can go like 15 divided by 5, and I get 3. The fact that they can divide evenly, like that also makes them a factor pair. So again, it's whatever way you'd like to think about it. Just making sure we're still recording. Sweet. So now we're going on to the product. Now this is a word you've heard before. This is a simple definition. Product just means multiply. It tells you to multiply. It also could apply to like the results. So if I wanted to find the product of 3 and 4, like I want to see like the end result looking for is 12. So it implies you multiply, but it also could refer to like the answer you get from multiplication. Should I write that up?
A result of multiplication.
The result of multiplication. Now, the divisible you actually saw a lot on the first examples. The divisible is talking about when I divide a number by another number, do I get a whole number answer? So let's think about 45. When I divide it by 5, I get 9. That means that 45 is divisible by 5, and frankly by 9 as well. It means divisible is talking about a number. When I say evenly, I'm talking about with no remainder. So if we ever say it divides evenly, we're saying it divides without a remainder. So you can't get a decimal, you can't get a fraction answer, you have to get a whole number answer for it to be considered divisible. And that leads into a remainder. The remainder is any part of a whole that's left over. So a really good example we had was 45 divided by 2. That gave us 22.5. The remainder is this part right here. It's whatever's left over that's not that entire whole. This is part of the whole. It means that 45 is not divisible by 2. And again, divisible means it does not divide evenly. Like we can obviously divide those two numbers, but divisible means it does not divide evenly. It gives you no remainder. This does give us a remainder, so it's not considered divisible. So we're on page 3 now. You should have done all of the examples up until this point. So if you haven't, just pause, go back and do pages 1 and 2, and we'll be here waiting for you on page 3. Okay? Notice these 3 observation questions. We are not going to go over these now, but you absolutely should have very well thought out answers. We will talk about these in class, and the more effort you put in now, the better prepared you are for class and able to have a good discussion. So please consider these questions, have good answers, and we'll talk about it next class. All right, right here we have factor pairs. Again, we already have this definition. I'm not going to rewrite it for you. So refer back to your first page, and if the definition we gave you doesn't really make sense, then we strongly urge you to write it in your own words. But make sure you have this definition written down. If you don't, you didn't finish your homework, so make sure you do so. One hint that we can give you, though, in helping you to remember this, is think about each word individually. Think about what factor means, and recognize that it has the word pair, which usually implies a couple, like there are 2 things there. Okay, so that should help you in recalling what this term factor pair means. We're looking at, right here, find all the factor pairs of 6. The cool thing is the process we showed you for finding factors, you're actually going to do the exact same thing. So step 1, take the square root of 6, and we get
2.45 approximately.
Now I notice we're going to round to the nearest whole. Okay? If you wanted to be safe, you could ignore good rounding rules and round up, but it's just not necessary. We're going to round to the nearest whole. This is not greater than 4. It is 4, so it's going to stay at 2. We're going to write 1, 2, take 6. Divided by both of the values, we get 6 and 3. And right here, the circle we were already doing, these are your factor pairs. Those are the factor pairs of 6. There are 2 factor pairs. If you're going to write a good answer on a quiz or a test, the factor pairs of 6 are 1 and 6. 2 and 3. It's really important that if it asks you for the factor pairs and you all just list the factors for us, we're not going to give you credit for that because we feel like you didn't really answer the question. Like it didn't ask you for the factors, it asked you very clearly for the factor pairs. So we want to see this information, 1 and 6, 2 and 3. Right, those are the factor pairs. Same idea for 72. Question, Ms. Hyder?
Mr. Riggs, if I wrote down 6 and 2 as a factor pair, how can I check that they're factors if they're not factor pairs?
That's a really good question. So notice how these are your factors, 1, 2, 3, and 6. But if you listed okay, 2 and 6 are my factor pairs, well, the way to check to see if that's actually true is just multiply those values. If I multiply 1 and 6, I get 6, and that's my target number. If I multiply 2 and 3, I get 6, that's also my target number. Your factor pairs should multiply to get your target number. I'm not going to say key point, write that down. I'm going to say that, I'm not going to write it down. You should absolutely write that down. Key point your factor pairs, multiply back to get your target number. That's a good check to see, did I really find all the factor pairs? We're going to repeat the same thing for 72. Go ahead. So take the square roots.
8.49 approximately.
8.49. Trying to round it to the nearest whole number, the nearest integer. This is going to round to 8. So I'm going to quickly list 1, 2, 3, 4, 5, 6. Now you just hear me counting. It's so much fun. Do 72 divided by all of these. First one's easy, we get 72. You should start noticing this pattern. It's going to help you answer these observation questions. Next we get 36, we get 24. 72 divided by 4 is, hold up, half. It's okay, thank you, Ms. Hyder. Now I know this is going to be a decimal. 72 divided by 5.
14.4.
Yeah, I'm going to cross through it because I'm trying to find factor pairs, and if it's not an even number, it can't be a factor pair. Next we get 12. 72 divided by 7.
10.29 approximately.
Dot that dot and keep going. And then 72 divided by 8 is 9. So right here I have all of my factor pairs. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Those are all my factor pairs. I'm not going to write in a full sentence because I don't want to take up too much time on the video, but you should. And now let's answer these questions. How many factors does 6 have? Take a second, think to yourself. So if you count carefully, it has 4 factors. But how many factor pairs does it have? It has 2. You should notice that the number of factor pairs is going to be half of that because it's pair comparing to all of the factors that you have. How many factors does 72 have? 12 factors. That gives us 6 factor pairs. If you want to be quicker, you can just count the factor pairs and then multiply by 2 to find how many factors are left. This is all we have for you right now. Make sure you do all of the practice through page 5. That'll end this objective. Come with it ready to work tomorrow, and we will see you all then. Goodbye, Ms. Hyder.
Bye.